So the title of this one is security. What we're really going to talk about is the access control lists. Access control lists are filters. And what they're going to filter on is either the IP address or a combination of IP address and service or port number, TCP port number. We're going to have two different types of access control lists. And he says, oh, there's really three. There's one called name. But name is either going to be a standard list or an extended list. And I think, and this is just me, I have absolutely nothing to back it up, the standard lists were probably the originals where you can only permit or deny, and that's all we can do is permit or deny the source IP address. And you can do it for an individual IP address, a subnet. We're going to use wildcard masks. I know everybody loves those. It's just a subnet mask subtracted from 255, 255, 255, 255. But what we're going to do is limit access to our resources, to our services that are running on the servers. And that's where services generally run are going to be on servers in the stack. The top part of the OSI belongs to the computers. But the objectives in this one is describe the types, features, and applications of ACL's access control lists. Standard, sequence numbers, editing, extended, named, and numbered. The log option just allows you to log what goes on with the list. Configure and verify in a network environment. That's really just a matter of setting it up and then saying, okay, I want to try it out and see if it actually does work. Keep in mind that if you do something on a router and you don't use that famous copy run start and you screwed it up, all you got to do is restart the router, because it's going to be, the old configuration is going to be in the startup config. So when you do routers and doing the labs in the simulator, not that big a deal, but when you're doing routers, if you really mess something up, just restart the router. As long as you haven't copied the running configuration to the startup configuration, it's probably a good idea to wait and be sure it works before you do that copy run start. Just a thought. The access control list, the name, number, and log options, all of this stuff is in Chapter 12. And when we do these things, I do recommend that at some point you read the chapters before the lecture, after the lecture. It doesn't matter. My personal thing, I've always done better reading it afterwards, because if I read it before, it's like, what the heck is all this stuff? If you read it before, or skim it before, you can ask questions about it. But all of those things are there. Statistics, resolve access control list issues. There's something that I think we make difficult when really it's a pretty basic, straightforward system. You're either going to allow something to happen, or you're going to keep something from happening. It's going to be permit and deny. That's the only thing that you can do with these things. I'll do the whole lecture and then we'll go through the slides. What we do is we add permit or deny statements. When the packet comes in, it has to go up, and I'll do my little pretend stuff, goes up to the access control list and says, I want to get in, or I want to get into this interface, or I want to get out of this interface. The access control list will then say, okay, show me your TCP IP header. And it's going to look at the TCP IP header, and you're either going to permit or deny based on IP address and port number. The standard only on IP address. And it's either going to get in or get out of the router. The access control list controls routed traffic. It's not supposed to affect any traffic that originates on the router itself. So that's what we're going to do with these things. The access control list, we put in the statements. They're a pain in the rear. You have to type access list and then the number, because they're based on numbers. Every time, unless you do a named list, and then you just have to do it once. And you can use either the named list, or either going to be the standard list or the extended list. So when this packet comes up, it starts going down the list of statements that are in the access control list. And it goes down the list until it finds one that applies. Once it finds a statement that applies, it obeys that one and doesn't look any further. So order in an access control list can be important. For instance, if you said that you wanted to deny me, my computer, access to the internet, then I could put an access control list that denied my IP address, that went out of the interface that went to the internet. If I didn't put that first, then I might still be able to get on the internet. The last statement that we don't see, there is what's called an implied deny everybody everything. So you have to have at least one permit statement in an access control list, be it a standard list or an extended list, at least one permit statement. So if I were going to deny me, I would deny my IP address, deny access control list 1, deny 192.168.3.3, or I could use the word host 192.168.3.3. Enter the next access control list 1, permit any, or permit IP any or something like that, which would permit any IP address. If I permitted, so what I would do is I'd go in and the first statement would say, oh, you can't go. So I'm denied access to the internet. But you go in and you say, oh, that's not my IP address. You go to the next statement, so you can go. You never get to the last statement which says deny everybody everything, which is built in. You can't take it, you can't make it go away. So you do have to have at least one permit statement in these things. It takes the first thing it applies, so that if we had the permit any at the front end, mine would see permit any, say, hey, I'm going to the internet, even though the second statement would deny me. The other thing about access control lists is that when you add statements to it, they're all added to the bottom. When you start writing these things, my recommendation, and he says in the book, use Notepad. Don't use WordPad, use Notepad, which is a true text editor to write these things. That way, if you want to change it, all you got to do is change it in Notepad, copy, and paste it into your router. And yes, that works in Packet Tracer also. You can write it in Notepad, copy and paste it, which is going to then put it in the order that you want. Because if you did something and say, oh, I need to put this one up here, can't do it unless it's in a named access control list, and then they're going to be numbered. And you can add numbers. You could do 10, 20, 30, if you could put a 15 in, which would put it in the middle when we do those things. The extended list use the IP address and the service, the port number. And that's where port numbers start coming into play. We use a source, actually we use a source IP, the destination IP, and the port number when we do those. So what we want to do, and what this is showing is, can't resist these things, coming in from the internet, what we have down here is a DMZ, a demilitarized zone, and typically what you're going to have in here is an email server and a web server. You may have some other stuff, but this is generally what you're going to have. The web server down here is going to be HTTP, you get over here, TTP, I lost my H, didn't I? And HTTPS, those kinds of things. So we're going to use port 80 and 443, and we'll also have an IP address. So what we can do when we come through this stuff, and this firewall is a three-legged firewall, which will have an access control list, will allow anybody to get to these services. Because if you're on the internet and you're selling stuff, you really like people to be able to get to your web server. You probably don't want them to be able to get to anything else. And what we do not want them to get to is over here is this private network, which is where we are, where you are at home, and your house is your private network. You're running a firewall unless you've really turned it off on your home router. And then we have an internal router, much larger network when we do these things. So what we're going to do is to permit permit anybody to get to certain services. The email probably going to be maybe something like port 143, which would be IMAP. You might have SMTP if you wanted to allow port 25. That can kind of be dangerous. Port 25 is what hackers look for to be able to send spam. They're looking for an open, what they call an open relay host, which doesn't require any authentication to send emails. If you're a spammer and you find one of those things, you're in heaven, because you can send emails like crazy on somebody else's dime. And then you might have the post office protocol POP. So what we're going to do is write an access control list that allows the source to be like any, because we don't care, right? And we can use certain words, any. I was talking to Craig with earlier, use the question mark, particularly when you're learning the commands. Use the question mark. Use the question mark once you start. Use the tab key to complete the commands. Make a lot fewer typos. I make a lot fewer typos if I use the tab key. I make a lot of typos if I don't use the tab key. When you take the CCNA, you can use the question mark. You can use the tab key. So, kind of get in the habit of it. And when you're doing these things, we can do that. So we have the source to any, and then the destination. We would have like two statements in here. The destination would be the IP address of this one. And then we could say host, whatever the IP address is, and then equal, the command's going to be equal 143 and 25. Cisco's going to interpret for you. When we put in port 80, and then you look at your access control, it's probably going to say something like web. When you do DNS, port 53, it's going to say something like domain. Don't get excited. You can either put the name in or you can put the port number in to do those things. So what we want to do in the security is filter these things out. It says the DMZ can be global, real internet addresses, which means that we can have routable addresses down here, or we can have private addresses and NAT, and that's the next chapter, where we actually substitute public addresses for private addresses. You may or may not. If you ever do port forwarding at home, that you're doing the same thing. What you do at port forwarding, you have your firewall out here, which has a public IP address. And port forwarding, if I were going to do port 80, for instance, I would forward port 80 to a private IP address, a 192.168.1.1, whatever, that's on my network. And I could be running a web server back there. So that if people knew to go to mine, or if you used an open DNS and they knew to go to the name that you used, once it got there and said, oh, I'm trying to get to port 80 through this router, this firewall, the port forwarder says I should go internally to this IP address. We're going to do the same thing with this down here. Down here we could either use private addresses and do that, or we could use public addresses and just route them in and route them out. So you can use either public or private addresses with these things. So some of the stuff that I think we've talked about, access control lists, the list of conditions categorizing packets. The list of conditions is probably not going to be all that long. Controls traffic in a network. Who do we want to allow where? One of the things that probably is handy, let me go back to this thing here, is on the private IP, private network, what can get out? We have a lot of people that are trying to hack a lot of network, trying to do different things. If you filter, and you can filter outgoing traffic, you can prevent your network from being compromised and becoming part of an attack network. So you can filter traffic in, you can filter traffic out when we do these things. To file with commands that are executed top to bottom until you find something that applies. Once it finds one that applies, it executes it and stops. And then it stops. It doesn't look down to see if there's anything else. Is there a better deal? That's what we always want, right? That's why we don't buy stuff, because we want to see what was it, the fear of a better deal. That's one, somebody's got one of those ads. But there's not going to be any better deals. Once it finds something that applies to that packet, it's going to execute it. The three rules are compared with each line sequentially down the access control list. It's compared with the lines until a match is found. As soon as a match is found, the packet is filtered accordingly. It does whatever it is. And again, it's going to be a permit or deny. There is also the implicit deny at the end of all access lists, which means that we need at least one permit statement in order to make these things work. Otherwise, you're going to deny everything. Seen that happen. Network administrator had somebody that was doing something really strange, but the powers that be had decided that this individual who had a static IP address should not have access to the internet. So he went in, wrote his access control list with his deny that IP address, applied it, and the internet immediately went down for everybody because of the implied deny at the end of the access list. We don't have to deny everything else. It's automatically done. So you need at least one permit statement in order to make these things work. These are some things that it can help with. IP spoofing. One of the things IP spoofing is, you shouldn't allow into your network any private IP addresses. I think 1918, if you ever, the RFC, they call them RFC 1918 addresses. They shouldn't be coming from the internet. You shouldn't allow any addresses in the header that are on your private, or they're on your network, even if you have public addresses. Originating traffic, enter traffic, that's okay. Denial of service attacks, ICMP, we can start or stop, and this is, ICMP is what we use in the ping world for Windows. Linux actually uses UDP for its ping. So ICMP is its own protocol. It's where we get the error messages, and that's what we use for ping, the request and replies. We can allow that or not allow that. Traceroute, which actually uses ICMP. Do we want to allow it? Don't we want to allow it? A lot of, and probably your network is set up, a lot of people don't want to answer pings. Because if you don't answer pings, do they know whether it's a live station or not? Probably not. You can do scans and find some things that are out, but you can use the access control list to not allow pings to be answered. So these are the type of lists. The standard list, and I think I covered a little bit of this, use only the source IP address, can't draw a straight line, as the condition of the test, so we can deny or permit host 192.168.1.3. Pretty simple statement of this one. The extended access list uses the other field. It uses layer 3 and layer 4. It uses the IP and the port number. And the port number based on whatever service we're trying to allow or deny. The named access list, and this is out of his book. Hey, wait a minute. I said there are only two types. It is a name list. It has a name instead of a number, which is really still going to have a number anyway because of these things. But there's still going to be a standard or an extended list, even if you use a named access control list. So standard lists are based on the source IP. The numbers for them are 1 to 99. So the standard, we're going to start out with access list, and then the number 1, and then the next thing, write the question mark, and it's going to say permit or deny or remark. We're going to deny host whatever. Once we write the access control list, ain't done nothing yet. It's kind of like if you were having a party and you had a guest list at the party, you write up the guest list. It doesn't do anything until you hand it to the bouncer and says only these people can get in. That's what we have to do with the access control list. Eventually, we're going to have to apply the list to an interface. Have a name because they are placed close to the destination. The way I remember this, my first ship, and you can remember it however you want, you only have to remember one, was in San Diego. Nice place, great weather. So I always remember SD, simple or standard access list, go close to the destination. That's because if we had a router here with multiple interfaces, we want, and we had the service here, we would want to put the access control list on this interface. If we put it on this one over here and didn't let that one in, and since we can only use it on an IP address, it couldn't get to the services here and here. So you want it close, the standard list close to the destination. And when we do these access control lists, we can have one per interface, per protocol. There's a lot of pers. Per direction. We can either apply them in or out. And in or out, and I've got a picture here, they call it the man in the router, the little guy in the router here. I'll make a little stick figure. It's based on the man in the router. If it's in, it's coming into the router. If it's out, it's going out of the router. So we can apply them one access control list per interface, per protocol, per direction. And the only protocol that we really use it anymore is our IP. So here is what one would look like. Access list 1, deny 192.168.1.1, 0.0.0.295, a wildcard mask. And what the wildcard mask is what we're really taking here is the increments. Remember the increment from subnetting, and subtracting 1 from it. So 255.255.255.0, the increment, we're going to have 256 total addresses in here. We subtract 1 from it, and it becomes 255 for the wildcard mask. Access list 1, deny host, and we can use the word host, 192.168.1.1, or we could use 0.0.0. What would it be? Anyway, whatever it's going to be for 1. What these wildcard masks mean is the 0 means to check. So what the 0 says is to check, is it 192? To check, is it 168? To check, is it 1? The 255 means I don't care what it is. It can be anything in that range. So this could be from 1 to 255. Or 256, actually, couldn't it? In addition to the deny, we can have a permit or remark. And the remark is handy to what's it for. Because if you only have one access control list, not a big deal. If you have 2 or 3 or 4, it might get confusing. So you may want to remark the access control list. This is deny Larry access to the internet for that one, so that when you go in, you know what that access list does. Access list 1, deny any. This is something that I guess you could put in, but based on what we know that there's already there, deny everybody everything at the end. We need at least, so this has a deny and deny. We need a permit in here somewhere. Otherwise, it doesn't matter that we denied this host or we denied this network, because the implied deny at the end of the access control list is denied everybody else everything. The extended list filtering can be done based on the source and destination IP address And the protocol types, IP, UDP, TCP, ICMP. All of those can be used in here. We numbered the extended list from 100 to 199. So access list, and it's access dash list 100. The system automatically knows that it's an extended list, so I can deny, and I can have the source IP, destination IP, and deny TCP. And TCP tells me what protocol I'm going to deny. TCP, the source, the destination, and then at some point we're going to say equal to 80 maybe when we do these things. I'm going to do a couple of examples, or at least one example of a standard as well as an extended list. So you get that. We got some options. So this one would say access list 100 deny TCP host 192.168.1.1 host 192.168.2.1. We're denying an individual access to a web server. Host equal, we have an equal sign here, equal to whatever. You can actually deny multiple protocols in a single statement. Should be able to do that. I say that, I know you can do that in Linux. I think you can do it here. So the options, instead of this, we could use UDP, ICMP, or IP. What the IP would be used for after this, because remember, we're going to have that implied deny. We could access list 100 permit IP any. A little bit shorter. What this says is let everybody else get there. But we have to have at least one IP. And then both, if IP is permitted or denied, both UDP and TCP are permitted or denied, both of the protocols. Attaching it to an interface. I said once we have written the access control list, it's like a guest list. That's the best that I can come up with right now. Until we give it the guest list, we're going to give it to, we'll call him the bouncer, whoever's the doorkeeper. And when you come up to get into the party, the bouncer looks at the list and sees if your name's on the list. If your name's on the list, he lets you in. So what we're going to do for the access control list is we're going to apply it to the interface. So remember, that's what routers use, the interface, where it's going to send the information. And what it's always looking for is what interface that information is going out of. So what we have to do is interface fast Ethernet 00. We have to specify the protocol because remember originally, although IP is about the only thing we use now, there used to be other protocols on these routers. Some of them still have protocols on them. Some of the older ones still have protocols on them. They may have IPX, they might have AppleTalk or something like that on them. So we have to specify the IP, and then we call it an access group. And the 100 is whatever the number of the access control list was. So mine would, I was using access control list 1, be IP access group 1. So we then would have applied it, and then we either have to apply it as going in or out of the interface. And we have to specify in or out, and I think that if you don't specify, and it's something that I should have checked and I didn't. I think that the default is in, but I won't swear to it, and maybe it is. Telnet uses the VTY, the virtual terminal, which remember was line. VTY 04 did all that stuff. When we have to turn it on, it's off. We'll do access list 10. We'll do an access list just like before. Access list 10 permit host 192.168.1.1. Once we do that, once we permitted that one, we don't really need to do anything else if everybody else is not going to be able to telnet there. And then we would go to the the config line VTY04. And this one, instead of an access group, is an access class. And we're going to use in because it's going to be coming into the virtual terminals when we do those things. The direction, and I've got my little guy here, this is the man in the router. I know it's a stupid looking thing, but hopefully it'll help you remember. Inbound traffic coming into the router, outbound traffic here coming out of the router. And this is for routed traffic. And we could try it out and see if I've lied, but I have read, I didn't try it out before I came in, that traffic that originates on the router is not affected by the access control list. Okay? These are some examples. Configure access list 10 deny. This deny 172.168.16.0, 0 to 0 to 0 to 255 is going to be the entire subnet. And then the access list permit any, the interface, the IP access group, and group goes with access lists for TCP for the interfaces. Access class is what we use. VTY is class. Fast Ethernet and serial interfaces are going to be access groups. And the access group, again, this is 10, I wrote over it. The access group is the same number as the access list. Standard list, this is just more of the same. Access group, this instead of going in, this one just goes out. Interface fast Ethernet 0 on this thing. We're going to deny it on traffic going out because we really should apply the standard list as close to the destination, going to San Diego for vacation, as close to the destination as possible. Extended lists, and I don't have a good one for this, just remember the extended one should be as close to the source as possible. It's a lot more specific, so we can do that. This is, again, the standard. Let's get to an extended list. Here we go. Config T, access list 110. Remember, the numbers are 100 to 199. There are some extended ones. Deny TCP any host to 172 equal 21. We've just denied FTP on 172.1650.5 to down here. We're denying any host access to the FTP port on this thing. Deny any host to the telnet. I guess I lied. You have to have different. I swear you can use that. Well, we'll see. I'll look that up on these things. And then permit IP any, because if we didn't do this, regardless of what we did up here, it would be a deny any. And then we go to interface fast Ethernet 01. This one, and they're applying this one out. And the reason that they do this there is because it's not coming from a single location. It's coming from multiple locations. So the first place that you can actually apply that and get both marketing and sales is going to be on the Fast Ethernet 01. The commands that are used to verify this show access list. You can show a specific one. Show access list is going to show the access list, its parameters. Does not show you which interface that it's applied to, however. The IP access list, you can read these. These are in the book. Reveals the parameters for access list 110. IP access list, all the IP access lists, which are basically what we're going to have on any of them anymore. IP interface displays which interfaces have access lists set on them. And to show the running config is going to show you the running config. It'll show you the access lists as well as where they're applied. Monitoring show the things that we just did. Show IP access list interfaces. Try these things out when you're doing the lab. So that's it for the theory of access lists. What I want to do, I'm going to stop this.